Hi, everybody. Let's see if I can get my slide to show up. Nope, that didn't work. The title of my talk is Environmental Benefits of Increased CO2. Well, first of all, some of them are not cause and effect. And you'll see some of them are negative. Can you have a negative impact that's positive? You certainly can. And you can have positive correlation or inverse correlation. See if I can get this to move along. First of all, the really known benefits, everybody should know. And we had it in the panel before, that plants do better with more CO2. This is from Sherwood Itso. It's a well-known slide. I hope you've all memorized it because I think you've seen it more than once. Here's Sahel. This is a vast swath of Africa. And you see the greener part, very little drought involved. This green part didn't exist 20 years ago. It's due to CO2 increase and plants' better ability to handle water. Now, this is a slide you're going to see quite often. I'm going to repeat it. All right? Sea level rise in CO2. Is there a cause and effect? And the answer is no. Spelt in red, capital. And does it rise or decrease, influence the other? Absolutely not. We will get into some real detail here. Now, I've been asked by Joe Bass to talk a little bit about the NASA TRCS, the real, the right climate stuff group. Interest started out at Johnson Space Center in 2008, and then we had a series of lectures beyond that. Our members are astronauts, physicists, engineers, even a meteorologist. About 1,500 years of combined experience in our membership. In Chicago, ICCC-12, Hal Dwaran, our chairman, over there, wave your hand, Hal. Hal, that's it, hi, okay. Anyway, announced the formation of the right climate stuff, and this was really helpful because we got attention, we got members that we wouldn't have gotten in any other way. So we've had dozens of lectures. Some of them, by the way, are recorded on our website, run by Jim Peacock, and he's over there too. Some of them weren't, and this is unfortunate. And I'm talking about lectures that are drawn from the expertise of our members. And that expertise runs the gamut. Now, I remember one particular lecture where Hal and I talked about the deviation analysis, the kind of research that NASA did that found out what was wrong with Apollo 13. And we applied that to climate. And the deviation, the greater the deviation, the greater the problem. And I think we concluded that there wasn't sufficient deviation in climate to make it a problem. That, unfortunately, was not recorded, but we have a couple of others that were, including about a month ago, Hal did an update on his sensitivity to doubling of CO2. That's online, worth a look. We also want to thank Heartland for letting everybody know about it. So we're going to talk about weather and CO2, weather events. And the cause and effect, by the way, you have all been misled. You've been told there's more hurricanes, that they're stronger, more tornadoes. Every one of those things is false. We're going to get into that in a minute. But now I want to look at temperature. Temperature and CO2 is supposedly related, right? Yeah, not quite. If you take a look at the green line crossing the graph, it represents CO2 at 280 parts per million for about 2,000 years. And you notice you have a rising medieval warm period, you have a little ice age where temperatures plunged, and absolutely no change in CO2. If CO2 influenced it, the influence isn't visible at all. But underneath that blue arrow, on the right side is a subset. And that subset begins basically in the industrial age when human contributions to CO2 began rising. And here's what the subset looks like. And this is taken right out of the National Climate Assessment. And you notice for the first third, temperatures are still falling. even as CO2 begins to accelerate upwards. Finally, you have a coincidence of temperature rise and CO2. But look at the top of the graph. All of a sudden, you see CO2 is still going up. However, temperature, and this is the famous pause, is not. And that's basically the pause. And at the last ICC, in a response to a question, we were asked about the pause and the new study that Carl came out with. And that's where I came up with my arsenic and oatmeal analogy. And it's worth taking a look at that. And basically, I'm saying if you mix bad data with good data, you only end up with bad data. You can't make it better. Now we're going to talk about weather events. You've all been told we have more hurricanes, right? Wrong. This is the hurricane strikes for the US. CO2, by the way, is on the bottom scale, and it moves from left to right, increasing parts per million. So you could very logically say, this is actually an inverse correlation, that the more CO2, the less hurricanes. Well, it happens to be an observation, is not cause and effect. How about energy? This is a concept called accumulated cyclonic energy. And what they do is every 6 hours, they measure the wind speed of a tropical cyclone, and tropical cyclones include hurricanes, by the way, pressure, strength, and they come up with a statistic, which is measurable, of the accumulated energy. Now, since we started this statistic, there's really been not much of a change. But for the last 15 years, there's a decided drop in cyclonic energy, even as CO2 continues going up. Here's tornadoes. Every category of tornado that we count is either going down or is flat. And by the way, in the 1950s, there were tornadoes that would form, come onto a cornfield, lift up, no one would ever see it, and we would never even know there was a tornado. Now we have radars. So the frequency that we're counting on tornadoes actually is higher now, and even in the face of that higher frequency, we still have fewer tornadoes. And the same is true, by the way, for CO2 and temperature. As they rise, the tornado counts are down. Yes, you have a couple of outliers here and there, but there are fewer tornadoes. Again, more CO2, less danger. Here's worldwide precipitation. Anthony Watts provided this graphic. It's pretty neat. Basically, for 100 years, we have flat precipitation. CO2 has gone up. There's been really no change in worldwide rainfall amounts. All right. Remember this slide? Sea level rise in CO2, is there a cause and effect? No, there isn't. All right. I'm going to show you some graphics. On the left, you see the results for the 20,000 years at the end of the last ice age. The great glaciers melted. In fact, they melted really within a 7,000-year period, if I can get that to show up, and that's a central 7,000. And there's a couple of blips in there, and I'm not so sure that they're real either, because a lot of those measurements were made in the island of Tahiti, and Tahiti probably tectonically fell off its volcanic plume, and as a result caused a spike. But within 7,000 years, almost all the melting was gone. The right graphic, it's a little more telling. Notice the last 2,000 years, sea levels are essentially flat. Now you notice there's a little red arrow. Let me see if I can point to it with this thing. No, that's not working. Anyway, there's a little red arrow on the top graphic, and that shows the predicted sea level rise that Jim Hansen claims is going to occur within the next 85 years. We would need new laws of physics to make that happen. If you look at the sea level rise for the last 2,000 years and figure out that all of a sudden we're going to get 5 meters of sea level rise, it's not going to happen. The diagonal slope you see is the rate that the so-called altimeter readings give. This is the satellite data. It is also linear, however, it does not match the sea level rise. And in fact, if you look at the University of Colorado website, they will state that we don't have a good feeling for the interface between the oceans and the, and the shorelines. Well, we measure it in the shorelines. So let's go on. This is a tide gauge. Tide gauge is up in Fort Point, New Hampshire. It's anchored to the bedrock. This is the bias in tide gauges. Why is there a bias? People put tide gauges where the sea level is perceived to be rising, and not so much where it's falling. On a worldwide basis, if you average the tide gauge readings, you're going to get a wrong number. You're going to get a bias toward rise. Excuse me. This is glacial isostasy. When you put a big chunk of ice, 2, 3, 4 miles thick, and you press down on the ionosphere, you get displacement. At the edges, you get a bulge. And when the ice melts, the Earth rebounds. And this is called tectonics. This is tectonics in the Baltic. The little red dot in the middle is Norway, where you have a huge 800-meter sea level rise as a result of the rebound of the melting glaciers. There is the transition line, you notice, is between yellow and blue. That is the zero tectonic effect line. I call these things isotecs, like isobars. So we take a look at that line. As you cross through, you see Nyborg, Denmark, is right on the zero line. So you know that if you're in Nyborg, you're not getting any tectonic effect, not uplift, not downlift. And this is what the graphic looks like. It's provided by Dave Burton. And you notice sea level is flat, linear. CO2 is rising exponentially, and yet there is no signal in that linear rise of the CO2. See the red dot in the bottom is at the 80-meter drop. So we're going to take a look at what's called cross-validation. That happened to be Wysmuller, Germany. You get 20,000 years of sea level of ice melt. 80 meter is the drop. So you should see a difference in 0.4 of a millimeter per year, and that's exactly what you see in the bottom graphic is Wysmuller, Germany. So we know that the tectonics that Niels Axel Mørne did when he made these charts is pretty much on target. This is the future of Fenway Park in Boston, all right? You're going to play baseball in rowboats, and that's Boston Harbor. Don't hold your breath. This is Boston, again, not much acceleration except in CO2, but the sea level rise itself is linear. These are stations nearby. Left is Portsmouth, New Hampshire. Right is Portland, Maine. Again, linear readings on sea level rise. And notice in the bottom, for the last 100 years, sea level rise basically hasn't happened in Portland, Maine. Here's New York City. This is what they think New York's going to look like. Not going to happen. On the left side, you see New York as it was when Henry Hudson first sailed up the Hudson. And the light blue part off Manhattan has now been replaced by landfill. They didn't make the landfill high enough. So on the right side here, where Water Street is, it's called Water Street because it was underwater. If you're at the South Street Seaport, you walk uphill to the original Manhattan Island. So here's New York, all right? Do you see any sign of sea level accelerating in New York? All right, here there's 2 stations nearby. New Rochelle's only 15 miles away. Same ocean, virtually linear, virtually flat. And by the way, that's true about the whole world. Sea level rise and fall is linear. It does not change because of the influence of CO2. This is what you're looking in the National Climate Assessment. They expect to see 6.6 feet by the end of the century. Actually, it's Hansen's worse. It can't happen. Take a look at if we are able to reduce the CO2 in the air as a result of the Paris proposals, we cannot measure the effect. If we can't see a 38% increase in CO2 having any effect on sea level rate, how are you going to get a 1 or 2% drop to be visible? That's what New York City is going to look like in the future. again, take a look at the serious part is there is no signal visible. All right, so there's the answer again. No, there's no connection between CO2 and sea level. Same with weather. This is what you need to be concerned about. And look carefully at the decline in the solar activity. And you notice there are a few parts near the bottom where you actually have 0 sunspots. Very few. Not true. And by the way, the cycle is now stretching. Willie Soon, one of the world's greatest solar researchers, was brutally attacked in the Washington Post, New York Times, Denver Post, you name it. And why? Because it was very obvious at the beginning of last year that all of a sudden something was going on with the sun, and they wanted to take his voice out of it. And Bob Carter, to his credit, did a beautiful job defending what Willie did. I'm not going to get into a lot of details about Willie, but take a look at what's really serious. Here you have, this is last August, you have days without sunspots. Notice, never in the middle of a cycle have we ever shot down to 0. And the same thing happened last month, by the way, for 5 days. This is a very serious issue that we need to study. Let's see if I can get here. There we go. That's our motto at NASA. And this is the public policy that I want to conclude with. Every model talking about CO2 and sea level rise is on its way to failure, absolute failure. And you name them all, including, this is one that New Hampshire put out. In New Hampshire, it's not even half the lowest possible reading that they could get. All the other ones are based on CO2 being normal or less and less and less. They are all wrong. Yep. This is the public policy I'm going to suggest, that we bar from use in any model that determines public policy of any sea level rise unless you get 10 years worth of impact, and that's 2 of those squares, by the way, where you pierce it on the upside. That's just not going to happen. Why do I pick 10 years? It's about half of a Saros cycle, 1/3 of a Saros cycle, which is what NOAA uses, and that way you get rid of the lunar effects on sea level rise. Only when that happens should we include CO2 and sea level rise in the models upon which public policy is determined. EPA's got to get back on mission. Poisons, carcinogens, toxins, and processes that kill people. CO2 is not one of them. Well said. I'm done.